This is a brief video on two concepts that are closely related, factorials and combinations. So first, let's talk about a factorial. A factorial is an operation that means take the number that you're looking at and multiply every positive integer, including that number, and below all the way down to 1. So 5 factorial is denoted with an exclamation point, and it means multiply 5 times 4 times 3 times 2 times 1. And if you perform that multiplication, you'll get 120. Let's do another one. Let's do 13 factorial. So 13 factorial is 13 times 12 times 11 times 10 times 9 times 8 times 7, 6 times 5 times 4 times 3 times 2 times 1. And when you calculate this, it turns out to be 6,227,020,080. Nope, I'm sorry, and 800. So you can tell by that number, factorials get quite big quite quickly. One more factorial I want to do before we talk about combinations is 0 factorial. And 0 factorial is a really special factorial because it's impossible to take 0 and multiply every integer, positive integer between that number and 1, because there aren't any. So 0 factorial is defined to be 1. So we would say 0 factorial equals 1 by definition. Might not make sense according to how a factorial is defined, but 0 factorial has to be 1 for other reasons. Okay, on to combinations and how they're related to a factorial. Combinations. Combinations are other operations that, let's see, the notation looks like this. Let's say n combined with j, or we actually say for short n choose j. Now, the applications of combinations to real life scenarios are really wide and varied. If you did a quick Google search on combinations, it usually comes with permutations too. It's a really interesting topic. But I just want to show you what the formula is for n choose j. So n choose j has a lot of factorials in the formula. It's n factorial divided by j factorial and n minus j factorial. So, for example, say you had 7 choose 3. So 7 choose 3 is 7 factorial divided by 3 factorial times 7 minus 3 factorial. Or 7 factorial divided by 3 factorial, let's see, 7 minus 3 is 4, times 4 factorial. Now for this first example, I'm going to write this out in red because there's a ton of cancellation that happens. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And the numbers are small enough that I don't mind writing all of them. 3 times 2 times 1 is 3 factorial, and 4 times 3 times 2 times 1 is 4 factorial. What is fabulous about having a fraction that involves a lot of factorials is there is a ton of cancellation that happens. So notice the way I wrote this, 4, 3, 2, 1, all cancels. So this 4 factorial totally cancels away with much of the 7 factorial. And I'm left with 7 times 6 times 5 over 3 times 2 times 1, but 3 times 2 is 6. So the answer turns out to be 35. All I have left is 7 times 5 over 1. So these are really difficult to put into a scientific calculator because the factorials are so large, but there's so much cancellation that the numbers frequently turn out to be rather small. Let's do a few more examples for practice. Let's do 4 choose 2. Let's do 4 choose 2. So that would be 4 factorial over 2 factorial times 4 minus 2 factorial. So that's 4 factorial over 2 factorial times 2 factorial. So this is 4 times 3 times 2 times 1, 2 times 1, and 2 times 1 for the 2 factorials. And just like in the previous one, this entire 2 factorial cancels away with a lot of the 4 factorial, and I'm left with 4 times 3. And then in the denominator, I'm left with 2 times 1, and that reduces a lot. 2 goes into 4 twice. So what we're left with is 2 times 3, which is just 6. Let's do a couple more. Okay, let's do 18 choose 0. So this is 18 factorial over 0 factorial. Remember, that's 1. Times 18 minus 0 factorial. Well, 18 minus 0 is 18, so this is 18 factorial over 0 factorial times 18 factorial. That entire thing cancels with the 18 factorial in the denominator. So we're left with 1 over 1, or just 1. Another example is 65 choose 64. So this is 65 factorial over 64 factorial times 65 minus 64 factorial. So let's see, that's 65 factorial divided by 64 factorial. Well, 65 minus 64 is 1. So this is times 1 factorial. Well, 1 factorial is just 1. So this is 65 times 64 times 63 times 62 times 61 times it all the way down to 3, 2, 1. And it's divided by 64 factorial times 1, but that's 64 times 63 times 62 times 61, all the way down to 3 times 2 times 1. And that cancels with the 64 on down in the numerator. The only thing that's left is the 65.